Hey guys, I hope you're doing well. Today I just wanted to go over with you our notes on Mercury since I haven't got to see you, and I probably won't see you for a little while. This will hopefully help you with your quiz, which will be on Wednesday. I'm going to separate this into two videos. So the first half, I just want to go over why exactly Mercury is named Mercury and how Mercury is moving in the sky. And then the second half, we'll go over a couple of the surface features of Mercury. So all the planets except for the Earth and Uranus are actually named after Roman gods and goddesses. So Mercury is named after this guy. So this is Mercury, who is also called Hermes, would be the Greek equivalent. And the reason Mercury is named after this guy is because he is the winged messenger. You've probably seen him in movies. He sometimes has wings on his helmet, or he has them on his shoes. If you ever saw the cartoon movie Hercules, the guy with the shoes with the wings, that's Hermes, and he can move really fast. That's why he's called the messenger god. So Mercury, the planet Mercury, is named after this guy because Mercury is the fastest moving planet. It revolves faster than any other planet. It takes 88 days for it to revolve one time around the sun. That's pretty fast. And the reason it can revolve so quickly is because it is so close to the sun. It's about 43 million miles away from the sun. So that's about 0.4 AUs away from the sun compared to the Earth's 1 AU away from the sun. It's also a really, really, really small planet. So if we take a look here, this is what Mercury looks like. You might notice that it looks very similar to something else we've already studied, and that would be the moon. The major difference is that there is no Maria on Mercury here. So there's lots and lots of craters, but there's no Maria at all. So there's so many craters. There's actually craters inside of craters on Mercury. So like I said just a minute ago, it is the smallest of the terrestrial planets. It's only slightly larger than the moon. If you're comparing diameters with the Earth, Mercury has a diameter that's about 2/5 that of the Earth. So it's quite tiny. That's why it's the smallest of the terrestrial planets. So this is what it looks like. And here's a comparison of Mercury to the moon. So again, the big difference, lots of craters on Mercury, but you will not find any of this Maria on Mercury. Maria is only on the moon. Okay, so here we're going to learn about a couple of Mercury's facts. If you have your chart that I gave you the other day online, go ahead and try filling this in as we go, okay? So first thing we need to know, I already told you the diameter is 4,880 kilometers. The radius is 2/5 that of the Earth. That's what I want you to know. I don't care about the actual number for the diameter or the radius. I want you to know that that's about 2/5 the size of the Earth's diameter and radius. So 4,880 kilometers diameter of Mercury, whereas for the Earth, it's 12,800 kilometers. So that's 2/5. That's what we need to know for our quiz and for our test. Distance to the sun, we said, is 0.4 AUs. We said that's 43 million miles. The sun is 43 million miles away from Mercury. So 0.4 AUs compared to the Earth's 1 AU, which is 93 million miles. Now, gravity on Mercury, since Mercury is a lot smaller than the Earth, the gravity is going to be a lot less as well. So gravity is 3.7 meters per second squared compared to the Earth's 9.8 meters per second squared. That's about 2.6 times lower the amount of gravity than the Earth's. Axis tilt is 0 degrees. So the reason Mercury has an axis tilt of 0 degrees is because of its location. Since it is so close to the sun keeps Mercury perfectly standing straight upright. There's no axis tilt at all, which means it also doesn't have seasons. The only thing it has a long daytime and a long nighttime, and it gets incredibly hot during the day and incredibly cold during the night. Mercury actually has the largest temperature change of any other planet, and that's because of how long it takes for Mercury to actually rotate. So we said that Mercury has a very fast revolution, but it's going to have a very slow rotation, and I'll show you that on the next few slides. Density. So Mercury has a very, very, very close density to the Earth. It has a density of 5.42 grams per centimeter cubed. And remember, if you recall, we said the average density of the Earth is 5.5 grams per centimeter cubed. So it's incredibly close, and the reason that is because Mercury has a bunch of iron in it. It's got a very large iron core, and then it has a mantle, and not much of a mantle. And we'll talk about why that is in a little bit as well. Okay, so rotation. Notice here it says rotation is 59 days. That is a sidereal day, not the solar day. One solar day is actually 176 Earth days, but it takes 59 days for Mercury to just rotate once. The reason it takes such a long time to rotate is because, again, since it's so close to the sun's gravity is pulling on Mercury, and it's not letting it pull around as quickly as other planets like the Earth. So it has a very, very, very slow rotation. So Mercury has a very, very fast revolution and a very, very, very slow rotation. So the revolution of Mercury is 88 days. It takes 88 days for it to revolve around the sun once. So 1 year on Mercury is 88 days, Earth days. So this just shows you how Mercury rotates as it revolves. So if you look here, you can see that where this little bump is, that's just showing you the starting point. And then it shows you how slowly it rotates as it's revolving. And I'm going to show you that as a little animation in the next few slides. Now, since Mercury rotates so slowly, Mercury has this thing, it's called a 3-to-2 spin-orbit resonance. 3-to-2 spin-orbit resonance. What that means is for every 3 rotations of Mercury, there are 2 orbits. Every 3 rotations, there are 2 orbits. That means that for every 3 sidereal days, there are 2 years. That's comparing the sidereal time to the revolution time. That's going to be different when we talk about the solar days, which I'll show you again in just coming up here. So if we take a look here, there's the sun. This line right here, this circle, this ellipse, I should say, represents Mercury's orbit around the sun. And then here, when Mercury is at perihelion, if you recall from our first unit, perihelion means that Mercury is the closest to the sun right here. So here we see Mercury, we see this side of Mercury facing the sun, and there's an arrow here. Here we're calling that day 0. So watch what happens as Mercury starts revolving around the sun. So day 15, day 22, day 30, 44, and then here at day 59, you'll see Mercury has rotated once completely, rotated 360 degrees. Now, this line is not facing the sun, which means we have not made a solar day yet. But if there were these background distant stars over here, this arrow would be facing those stars, and this arrow would be facing those stars. So that would be called a sidereal day. So that is one sidereal day. 59 Earth days is one sidereal day on Mercury. So let's keep going here, see what happens. So now we are at day 88. We have completed 1 revolution around the sun. Mercury has completed 1 revolution. So you can see that now the arrow is on the exact opposite side. So we have still not completed a solar day yet. So let's keep going and see what happens next. So that's day 88. Here at day 118, we're facing this direction again, these background stars. So that means that we have now had 2 complete rotations. So this would be 2 sidereal days. We keep going. And now finally, we are back facing original starting point facing the sun. So that's on day 176. So it has been 2 years, 2 revolutions. It has been 3 complete rotations, which would be 3 sidereal days, to have 1 solar day. That means that 1 solar day on Mercury is equivalent to 176 Earth days. So that's equivalent, that would be a 2-to-1 spin orbit resonance. For every 2 years on Mercury, you have 1 solar day. So it's a 3-to-2 spin orbit resonance. For every 3 rotations, you have 2 years. For every 2 years, you have 1 solar day, though. So this just explains, these are the words for what I just tried to explain to you. So Mercury has a very slow rotation, makes 3 rotations for every 2 orbits. But 1 solar day on Mercury is 176 Earth days. That is an incredibly long time for 1 day. So there are 2 years for every 1 day on Mercury. That's called a example of spin orbit resonance. So for every 3 rotations, you have 2 orbits. That is a 3-to-2 spin orbit resonance. go ahead and go over a couple more facts about Mercury here. So we've already said the axis tilt of Mercury is 0 degrees. The reason it's 0, again, it's because the sun's gravity is pulling Mercury around, and Mercury gets hit a lot. It used to get hit a lot. And those hits from those big asteroids and comets, whatever came to hit Mercury, it didn't actually move it out of its axis because the gravity of the sun pulling on Mercury is keeping it straight up and down. The orbital inclination is 7 degrees. Now, we talked about orbital inclination. We talked about the sun's orbit around, the Earth's orbit around the sun, and then we talked about the moon's orbit around the Earth. So orbital inclination means that if the Earth is going around the sun at 0 degrees, Mercury is going around the sun at a 7-degree difference between the Earth's orbit and Mercury's orbit going around the sun. There's a 7-degree difference there. So we are not in the exact plane of orbit that Mercury is in. Mercury has a 7-degree difference than ours. That's what that means. Surface pressure is 0 bars. So there isn't really an atmosphere on Mercury. There are gases on Mercury, but it's not an atmosphere. It's more of an exosphere. And so we'll talk about that in just a few minutes as well. I want to talk about temperatures. So we said since Mercury has a very, very slow rotation and it doesn't have an atmosphere to trap that heat, what happens is since it takes 59 days for it to rotate once, the side facing the sun gets incredibly hot, and the side not facing the sun gets incredibly cold. So it's got the largest temperature difference between day and night of any planet. I'm going to give it to you in degrees Fahrenheit, degrees Celsius, and Kelvin. So for Celsius, it ranges from negative 173 degrees Celsius to 427 degrees Celsius. So the difference here is nighttime versus daytime. For Fahrenheit, that would be negative 279 degrees Fahrenheit compared to 801 degrees Fahrenheit. And then Kelvin, which is what we use for astronomy, it ranges between 100 Kelvin and 700 Kelvin. So that is a huge temperature change going from daytime to nighttime. For the Earth's comparison here, you can see we have a range of between 185 and 331 Kelvin. So that's a huge difference between Earth's temperature between Mercury's temperature compared to Earth's temperature.